Alright, this is video number 3 for Siemens Energy, and what we have done is we have isolated 1, 2, and third board, so they are completely removed. We only have the variable frequency with just one single FCOREM60 board, and it's again powered from the same 120 to 24 volts AC. Notice that now the power requirements are only 420 milliamps AC. Now that it's not basically changing the power the element. Now on the variable frequency board, it's still power at 24 volts, but now the current it's 340 milliamps. Sig high, it's 10 volts, 0 to 10, and we have it on, we have it enabled. And notice that of course now we don't have connections to the probes other than just the one here for the plus A output on this board. We brought our Pearson transformer here to measure the current, and again we don't have signals to the DC chain. We are at 10 volts, and if we come here we are back at the initial conditions of 75 hertz. It's 10 volts, so we have our delay angle of 14, in this particular case 14.5 degrees. So I'm going to go ahead and open this up, and again we have the same 120 single firing profile. So start looking at this, and we see that here the amplitude went a little bit, but not by much. You know, notice before we were saying shy of the 3.5. Right now might be a little more, and one of the things we didn't open was to see the area under the curve, but at least the amplitude is just a little high. Then we had reported 3/4 of a division of, or approximately 150 amps for the trailing, the end of that pull string, and we took a lot. That's still the same. I'll probably say that it's the same. So let me bring it back, and I'm gonna ask Tony to change the sig high. Tony, go ahead and give me the sig high. So we changed the delay angle. So now if I come here again, so there it is. This time I'm gonna look at the trail, and again it's still the 3/4 of our division. And if I come to the initial, that's still, it's more like 3/4 or a little shy over 3/4 of our division, 775 milliamps. Now I'm gonna come back, and I'm gonna ask Tony to go from 75 down to 60 hertz. That's close enough, Tony. And we have sig high is 0. If I line this up, I should be able to get my delay angle of 160 degrees. And here we have our output. So now let's go ahead and close in and take a look at and we can see that at 60 hertz we have come down to a little over 3 divisions. Notice here, oh, that's probably the frequency here. So that's still the same at 200 microseconds per division. This is probably where I've been taking. I've been then here. We have again the 3/4 for that. Let me just come back here and open up this so that will probably be a good idea to send oscilloscope shots of something like this, where you can see truly the width of that pulse, not just the amplitude, because the amplitude could seem to change depending on how it's taken. Could be just an impulse, or it comes. Let's go ahead and move to 10.420. And again, we notice the overall amplitude. And again, that seems to be the same. And again, the important thing is that now the initial, it's definitely about 600 milliamps, and the last trailing pulse is still approximately 3/4 that, which is 150 milliamps. This is the end of video number 3.